Here's how to use a datasheet to find the right resistor for your LED circuit. We'll start with a datasheet for a standard 5mm red LED. Say I want to use this in a simple circuit with a battery and a resistor. I start by looking at the forward voltage, listed here as typically 2.1 volts, with a maximum of 2.6 volts at 20 milliamps. That's the voltage drop I'll use in my Ohm's law calculation to size the current limiting resistor. The recommended forward current is 20 milliamps, which will provide optimal brightness without pushing the LED too hard. The absolute maximum forward current is 30 milliamps, and the peak is even higher at 100 milliamps in pulsed mode. But again, we don't want to run that close to the edge. We can see that this LED's viewing angle is 35 degrees, which is fairly directional. I also love checking the graphs. This one shows how the current increases steeply with voltage and how brightness scales with current. All this helps me design a circuit that's safe, efficient, and performs the way I expect. So if I do the math with this LED's forward voltage and this 4.5 volt battery pack, I need to subtract the forward voltage from the supply voltage to get V in my Ohm's law equation. Divide that by the LED's recommended forward current to get the size of the ideal resistor in ohms. Since we know there's some wiggle room around the recommended current range, it's okay to round to the next nearest common resistor value. So if you've got a 100 ohm or a 220 ohm resistor, those would both work fine. Check out the full video about datasheets on the DigiKey YouTube channel. Check out the playlist with the rest of the series and subscribe to be sure you don't miss the next one.